Okay, so this is trig equations, which we did in trigonometry. The very first question is exactly what we did in trigonometry. Nothing new here. It'll just be a reminder on how to do it normally. And then from question 2 onwards, we'll be putting some radians in there. That's the only extra catch. Okay, so question 1, I want to solve the trig equation that sine of x is equal to root 3 over 2. And we're solving between 0 and 360 degrees, which means that in our all stations to central, we are going one whole turn around, right? From 0 all the way around to 360. So we are looking for the quadrants where sine is positive, because root 3 over 2 is a positive number, right? So where is sine positive? First quadrant, second quadrant. It will be helpful to have your exact value triangles handy. So let's quickly draw those. And the other one. Okay, so they're on your formula sheet, so you'll know you have those whenever you need them. So I need to know now, using my exact value triangles that I just drew, sine of what is equal to root 3 over 2. So, yeah, 60. So going over here, here's 60 degrees. Sine is opposite over hypotenuse. There's my root 3 over 2. So I know it has to be 60 degrees as what we call the reference angle that goes to the horizontal in both of those quadrants. Now in the first quadrant, that just means that that 60 degrees is my first solution, because that's first quadrant, the acute angle, that's it. When you're in the second quadrant, we call that the 180 minus theta quadrant, or to find the angle, we do 180 minus 60, which is going to be equal to 120 degrees. So my solutions are 60 or 120 degrees. Is that ringing some bells from doing that in trigonometry? Excellent. Okay, so here we have some more, but now the question looks so similar. You've got tan x equals root 3, so there's a trig equation. Nothing different about that. The difference is here, where it says I want to solve between 0 and 2 pi. Now, if 180 degrees is pi, 2 pi is 360. So that's another way of saying we're still going one lap around that all stations to central. So let's draw it again. Here's my all stations to central. And tan x is equal to a positive root 3. So which quadrants is tan positive in? First and third. So I have solution in those quadrants. Then I need to know what the reference angle is. Tan of what gives root 3? So back over here to my triangles. Tan of 60 again, how boring. Opposite over adjacent is going to be root 3. So 60 degrees in here, 60 degrees in there, always to the horizontal line. So my preference, and I'm sure probably a lot of you prefer as well, is to always solve these in degrees, which is what you can see I'm doing here, and only at the very end convert it into radians because it requires me to, because it says I need between 0 and 2 pi. Okay, so the first quadrant, it's an acute angle, so my first solution is 60 degrees. The third quadrant is going to be 180 plus the 60 degrees, which means 60 or 240 degrees. Okay, so we've solved it. Those are the angles, but now to put them into radians. To turn degrees into radians up here, you times by pi over 180. So each one of those, I'm going to go 60, and I'm going to times it by pi over 180. You can even make it one fraction straight up. So just put pi over 180 in there, or 240 pi over 180. And then just use your calculator to simplify this fraction for you. 60 over 180 makes a 1 over 3, so it's going to be pi over 3. Or simplify your other one, put 240 over 180 in your calculator. What do you get? 4 pi over 3. Excellent. See? Not too bad, is it? Okay, they're going to slowly get a little bit more involved though. Question 3. 2 cos squared x minus 1 is equal to 0. It's not the radian part that's going to get more complicated, it's just the trig equations are going to get a bit more complicated. So I want to solve that equation, which means your goal is always to try to get the trig function by itself first. Before you start worrying about quadrants and things, I need the cos by itself. So first of all, move the 1 across. Okay, then divide the 2 across. And you even need to get rid of a squared. Okay, we don't ever solve for cos squared, we want to solve for cos. So to get rid of a squared, you're going to square root of 1 is 1, square root of 2, unfortunately I have to put a square root sign in there, so square root of 2. However, when you square root, what else do you need? A plus and a minus. Now that is really cool because normally we only have 2 solutions. If it's a plus and a minus, where is cos, positive or negative? All 4 quadrants. We're going to get 4 solutions here. So here, 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 and here. Now don't worry about the plus or minus part. Where is cos equal to 1 over root 2? You can just see my triangle over here. It's the 45. Convenient, that was good, wasn't it? So cos of 45 is my reference angle goes in here. So now let's go around each of our 4 quadrants and work it out in degrees. The first one, acute angle, is 45. In the second quadrant, we do 180 minus 45. Now, I'm showing working out here just so that if you look back at this, you know how you got the answer. I'm very happy for you to go 45, 135, 225, 315, if you can go straight to the answers. But it might be helpful to show how you got them at this stage. Next one is 180 plus the 45, and the last one is 360 minus the 45. So that gives me the 4 numbers that I just said. 45, 135, 225, and 315. Solved in degrees, just need to put it in radians. So we're doing this thing in here where we just times it by pi over 180, each one of those numbers. So 45 pi over 180, 135 pi over 180, 225 pi over 180, and 315 pi over 180. And simplify them down. Am I going too fast or is this making sense? It is making sense? Wonderful. So first one, pi over 4. Next one is 3 pi over 4, 5 pi over 4, and 7 pi over 180. Oh, it's 4, sorry, yeah. Well, I'm like, why is that one different? It should be a 4. Okay, so next page. Okay, what else can we do to these trig equations to make them different? Let's put a 2 somewhere different. Let's put it in here to make it a 2x, cos of 2x. Just like before, I do need to try and get the cos by itself as much as I can. So it's going to be 2 cos 2x equals 1. And I can divide the 2 from the front so that it's cos 2x equals a half. However, please do not ever try to divide that 2 out. You can't, okay? We have to now solve this equation for 2x, unfortunately, because that is the angle that we've been given, a 2x in there. That means that if I'm trying to solve for x between 0 and 2 pi, if I am solving for 2x, I have to times each side by 2. 0 times 2 is still 0, but 2 pi times 2 is 4 pi. So I'm actually going to be solving, and usually we introduce a prenumeral here. I'm going to say let u equal the 2x. So I'm going to be solving for u between 0 and 4 pi. Okay? So using that little substitution, cos of 2x is going to become cos of u equals a half. That way it looks like one of the equations that we've been solving in the past. So we go cos of something equals a half, it's positive. Cos is positive in the first quadrant and the fourth quadrant. Now, if you have those triangles drawn down, cos of what gives a half? Too many 60s. Yes, it's 60 again. Okay, so in the first quadrant, u is going to be equal to 60. In the fourth quadrant, 360 minus 60 is 300. But that is only going from 0 around to 2 pi. Where do I need to go to? 4 pi. So I have to go around again. So the easiest way to do that is just add 360 to each of these ones. So 360 plus 60 makes 420. And 300 plus 360 makes 660 degrees. Now the reason is because remember that is 2x. When I now divide through by 2 to get x by itself finally, I will get 30 degrees, 150 degrees, 210 degrees, and 330 degrees. And you'll notice that all of those angles have now come back between 0 and 360 where we knew they had to be for the final answer. However, they're still not in radians. So let's do our last little convert part. So we're going to go 30 over 30 pi over 180, 150 pi over 180, 210 pi over 180, and 330 pi over 180. And that will give you pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Yeah? All right, question 5. Solve 2 cos squared x minus cos x minus 1 equals 0. So remember the goal is always try to get the trig function by itself. So the problem is that we've got cos in there twice. One of them squared. Oh, who can see what is going to happen with this question? Come on, excitement building here, people.
Sine.
No, unfortunately.
What?
Something squared. So this is like an x or a squared. It's a quadratic. It's a quadratic. It's a quadratic equation that involves trigonometry. Come on, how exciting is that? So, I know, I can see the smiles. Okay, so that's it. See, I can see it. All right. So when you can see that you got a squared, like an x squared, like an x and a constant, quadratic. So we're going to do a substitution. Not quite like the other one where we're subbing in for the angle. I'm going to sub in for the whole cos x part. I'm going to say let u equal cos x. Okay, I'm actually going to take the trigonometry part all the way out of this equation to start with. And so that's going to be 2 cos squared is going to be u squared. And minus cos x is going to be a u. And minus 1 equals 0. So that looks super nice because now there is no trigonometry at all. We just need to solve a normal quadratic. Now remember, this is non-monic, 2 out the front. So you're timesing the 2 with the minus 1, so that's minus 2. 2 numbers that times to give minus 1 and add to give them, times to give minus 2 and adds to give minus 1 is minus 2 plus 1. So we split the middle term to be minus 2u and a plus u minus 1 equals 0. And now we factorize in pairs. So the first 2 terms, we can bring out a 2 and a u, which gives u minus 1 inside. The third and the fourth term, we don't actually need to bring anything out of them because it's already u minus 1. But I am going to put it in brackets because that u minus 1 is now a common factor that can come out of both of those terms. So the u minus 1 comes out, and that means the 2u from the front here and a plus 1 that would be there makes the second bracket. Okay, now using our null factor to get what u is equal to. So from the first bracket, u is going to be equal to 1. Okay, from the second bracket, we'll have 2u equals -1, or u is equal to -1/2. Actually, wait a sec. If you haven't written that down yet, move that over. So we're going to have to do a bit of work. I'm going to put it over here. So 2u equals -1, which means u is equal to -1/2. Because for each one of those now, I have to bring the trig back into it. So remember that u is equal to cos x is equal to 1. And over here, cos x is going to be equal to -1/2. Now, cos of what equals 1? 1 is not, yes, 1 is not one of your exact values from your triangle. If you ever have numbers in here, there's going to be another one down here. This is going to be doing it again, this last example. If you have numbers in here that are 0, 1, or -1, they are the ones that you would normally do from your graph. They were what we call the boundary angles. Okay? So the cos graph, roughly, starts up at 1, goes down like that, and back up like that. Remember that graph? Okay? So it is at 1, here at 0. Was that a, I'm loving this, I'm going to hit my head on the wall?
No,
oh, good.
My head on the wall so you can see more. Using a little blood to support my head.
All right. So it is going to be 1 at the start, then it comes down to -1, and it is also 1 again at 360. So the solutions for that are at 0 or 360 degrees. What is that in radians?
2 pi.
So 0 is still 0. A 0 angle in degrees is still 0 angles in radians, right? And 360, you can do your times pi over 180 if you'd like to, but that's 2 lots of 180, so it does mean 2 pi. Okay, so there's 2 solutions from that first equation, from the cos x equals 1. Now I am to solve this one. Cos x equals -1/2. So that is one that we can use our all stations to central for. Where is cos negative?
23.
Yep, sine quadrant and tan quadrant. And cos of what gives a half? Yeah, did you just guess that? Because 60 seems to be our favourite number today. It is 60. So in the second quadrant, that means that x is going to be equal to 180 minus 60, which is 120 degrees. In the third quadrant, you do 180 plus 60, which is 240 degrees. And last little thing is convert it to radians. So it's 120 pi over 180 and 240 pi over 180. And that should simplify to 2 pi over 3 and 4 pi over 3. So 4 solutions. 0, 2 pi, 2 pi over 3, 4 pi over 3. Nice question, hey?
Lovely.
All right, one last one. Okay, last question. Solve sine x equals 0 for minus 2 pi to pi. Okay, now remember I said if the number that is there, is 0, 1 or -1, it's a boundary angle that needs to be done from the graph. Okay, so we need to do the sine graph here. Now the sine graph, and we're already doing that last exercise that we're going to do ever so quickly. The sine graph starts at 0 and does that kind of thing. Now normally that is 0, 180 and 360. Radians time, 0, pi, 2 pi. Okay? 0, pi, and 2 pi. Which means in between, if we need the in-between ones, this would be pi over 2 because you halve that space. And so it'd be 1 pi over 2, 2 pi over 2. This one's going to be 3 pi over 2. Now the problem is, that's the graph that we're used to drawing, but we actually only wanted up to pi. We only wanted, go back to my highlighter. Come on, highlighter. Anyway, there it is. Highlighter. We only want that part to pi. Okay, because it said to go to pi, but I need to go to negative 2 pi, which means I need to continue the pattern going this way in the negative direction. But sine is just one of those lovely repeating patterns. You just continue the same thing going the other direction. So extend that line out. We're going to go, this is going to be minus pi and minus 2 pi, which means minus pi on 2 will be there and minus 3 pi on 2 will be there. So continuing my pattern, the curve will go down and it'll be at negative 1 at minus pi on 2 and back up to 0 at pi, and then it will go back up to positive 1 and down to 0. So it's going to go like that. Just continuing the pattern. Please note that this should be a 1 up here and a negative 1 for the lowest point down there. So we are, now that we've got our beautiful graph, and we want all the way, all that highlighted part, that's the highlighted part that we're solving from. Minus 2 pi to pi. That part was just what we were familiar with, which is why we drew that to start with. Okay? Where is sine x equal to 0? There, 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 and there. Okay, so just write them down from the graph. X equals minus 2 pi, minus pi, 0, and pi. So there's 4 spots where that goes through 0.